So I'm Xiao Yun. I will start out the presentation first. And we are from the Water Quality Department of PUB. So PUB is a big organization. And we are one of the departments working with ASHRAE to develop this system. So let me move on. Yeah, so we'll just go through a bit about my agency's mission. And because we are very mission focused, everyone is a stakeholder here. And then before we go deeper into the water quality sampling system. Right, so I'll just spend a couple of minutes explaining our mission. It is summarized in supply good water, reclaim used water, tame storm water, resist rising seas. So basically what that means for the supply good water is that we have to manage our reservoirs and water sources to make sure that they are treatable using the current technologies to supply good drinking water to the whole country. And that is a very critical mission for us, and we have zero tolerance for failure. And then the reclaiming of used water is that we have to treat all the waste through the sanitary systems, convey them to our water reclamation plants, treat them for either discharge to sea according to standards, or we pump them to new water factories to produce water that we supply either to the industries, for example, wafer fab companies who require ultra pure water, or we pump that back to our reservoirs for further treatment. So currently we are doing indirect potable use. Taming of storm water, we have to manage our reservoirs and catchments. We don't want floods. Yeah, so we are always in this mix where we want more water so that we can treat water and supply to everyone, but we don't want too much water that will flood. And then resist rising seas is because in the last few years we were tasked to look into coastal protection for the country. So we have a dedicated department that working with various agencies in Singapore. So with all this mission, we are one of the departments. We are the water quality department, and basically our main role is we have to ensure water safety. And this is what keeps us awake at night. Yeah. And then, other than having more than 500,000 of tests conducted annually, and what I really want to say here is that we cover the testing of different water matrices, be it for the reservoir, be it for the sea, because we do desalination, be it for your drinking water, be it new water, be it the feed to new water. So we basically have to make sure that if you look at, we have to safeguard the source water, so whatever intended use, it could be recreation as well, so protecting the reservoir so that you can use it. We just had a triathlon. And then we have to have, so in my department, we have a dedicated group of analysts, scientists that test the water that comes from all over Singapore that is sampled daily. And then we have to establish the water quality guidelines in treatment and distribution. And every time we get either public feedback or we have, from our data, we notice that something doesn't seem to be typical, we will go down and investigate. And then there's a lot of rigorous audit. We actually have external audit panels that kind of audit us so that we are independent. We have independent people to see if we have gaps. And then the QA/QC frameworks, and we have to have regulatory compliance as well. Let me move on. Okay, so moving on to the motivations for water quality sampling systems. So in my team, I have a group of officers that brave the sun and the rain every day to collect water samples from different parts of Singapore. And we have to ensure that the sampling points are representative, so we have to cover the Singapore. So we have a program for that. And so what typically used to be is that, so they will go to the site, they will collect water samples that they will bring back to the lab for testing, but they will do some simple parameters first, and these are the initial parameters that will tell us whether the water is okay or not, atypical or not. So that will be things like how clear the water is, which we call turbidity, the conductivity is the salt level in the water, the chlorine levels in the water, and things like that. So these gives us a very quick information on whether this is okay. We don't have to raise an investigation. And so this is what is done by a sampling team. They will use portable meters, and then they will do it, and then they will record on pieces of paper the location, the data, and then they will take photos. If you move on to number 2, they will take photos because we need to have validation of the data, so we need to have proof that that was the real data that we get on the floor. right? And then they will record the test papers, they will label, and then they will use pieces of paper to label the bottles. And so that's done on site, and that's the blue portion. Then they will go back to our labs, and they will have to enter the test results into our laboratory information management system, which is the system that captures all our water quality data. And then so you can imagine there is, paper, there's transfer of a lot of data. And then they will also have to print out the photos that they took just now, so that, when the person who validates the data and ensure that that is accurate data, the person have to compare against the pictures of the portable meter readings. So, well, they have been doing it for a while, but you can imagine it's really time-consuming, and my guys don't really just do 1 point a day. They do many, many points a day. So that's actually quite a lot of work. So they were time-consuming, and we realized that we couldn't actually let them do more value at work, even though if we want to. So our vision and our goal then was that if we have a water quality sampling system, what we really want is really to have most of the things that we can already do on site and automated and fed at the back end without, a lot of paper transfer, recording, everything. So yes, they still have to go on site to collect water samples, test surrogate parameters and all these things. But what the water quality sampling system allows us to do is on that iPad, they could take pictures and okay, first of all, they will have the geospatial coordinates. So we can lock it in, and that's very accurate. So you don't have to write the site anymore. And then they take pictures of the data, the photos of the portable meter readings, and then they key in the readings directly. And then at the back end, or through the iPad, it will feed straight into our LIMS system, which is our Laboratory Information Management System. So they no longer have to print photos, they don't have to do all these things. And at the back end, while they are continuing to sample, people in the lab can really start to look at the photos and they start to validate the data, and the data can be released. So that really, really saves a lot of time. So a lot more tasks, so then they can spend more time while doing routine sampling. We could also deploy them to do things like investigations when needed, and to do more value-added work, which is really what will really benefit us. Yeah. So this is, in short, our objective would be we want to enhance the sampling process, which typically used to be a very manual process. And you know that, as our workforce shrinks, we really want our people to do really value-added work, rather than very manual work. So that could complement the existing data updates that's coming from the lab to the LIMS system. And then it's really allowing us to perform this task very efficiently. And it also, the kind of feedback we get from the ground is the officers also feel proud when they're doing things because it's faster. They feel good too. Yeah, and the outcomes is that the sampling team, my guys, they were able to view the assigned jobs. So now we could assign jobs now in their iPad. They look at it, they go there, they tag the geospatial, they confirm this is the correct site. And then they can key in the data, they can capture the photos of, be it the portable meters, or even sometimes if we want to do investigation, we have to capture the site photos. And then the data can be quickly validated, and there's really a lot of enhanced efficiency. So what I've just tried to describe is basically our business and why this was a pain point that we wanted to address, yeah, towards a bigger picture of ensuring water safety. So next, I will let Yi-Xing take on the subsequent slide. So because she was instrumental in really, so I have to borrow Cynthia's words again, BTS. So she did a lot of BTS. So, so I really let her describe the more technical parts of the water quality sampling system. Thank you.
Yeah, thanks, Xiaoying. So I take over for this tough task. We have gone through all the things. So we set our objectives. We also have our outcome, what we want to have it. So now it's come to this design. What are the considerations we need to take it? So we set these three key considerations. First of all, we want to have this water sampling assignment. So we want to use the GIS map, right, to show where to collect the sample. What is the work plan for it? So for the supervisor, they can assign the job in the GIS map. So the officers to spread out the work through the team. Then for the field officers, they can view the assigned job to him, right? They go to the correct places to collect our samples, and they will easily for them to check what is the daily assignment to him. And also he can plan where to go, which one to go first, which one go later. So that is the assignments. Then the second consideration is for the data collection. Because on the field, we have a lot of things need to collect, a lot of data need to be collect and key in. So which way will be better for them? So first of all, it's like we want to have a team to view and zoom in the places they went. They go for sampling. So it did happen before. Some of the samples are collected from wrong places. Look same or address, yeah, 456, 458 or something, they mix up. So with the MIS map, they can see, they can view, so the correct places. Second is we do sampling, we do have a lot of program. Each of the program might need different informations. So our sampling guys might miss out certain important informations. So we design for that, create a form to them, easier for them to follow, right? Yeah, so when we collect the data, we don't want to use the paper anymore, don't want to record, double keying, all this manual work, duplicate work. It introduced not just tedious work, but also introduce errors. So if the site people can direct keying the data into the system, and through the WQSS system, it will go seamlessly transfer the data to our LIMS system. That's good, right? Yep. So all this is the second consideration for data collection. Then the third one is labeling. Seems simple, you just label the sample, nothing big deal, right? But think about the old day, how people do. They write on a piece of paper, use the rubber band to secure on the bottle. How do you think? Yeah, during the transportations, the water will come out, maybe not closed properly, the paper wet, can't see the info. The rubber band, broken. We don't know which, the label is for which sample. That happened before. So we want to have a portable printer, bring on site, print out the informations and place on the bottle directly on the site. But here is there's a big trouble is like, not just we need information, we also need sample ID. Where we get this sample ID? This sample ID is generated out from LIMS, Laboratory Information Management System. So we require the WQSS can talk to LIMS, both way talking, not just submit the data, but also get the information from LIMS. So this is, we need to work with vendor, LIMS vendor as well. So it's not just the user, but other vendor as well. So that is the key design considerations. So after we're done, how is the system looks like? Okay, to fulfill the work assignment on the ground, we are using the Workforce app to do so, to assign the job assignment. For the supervisor, they can just use the iPad to assign the job to the staff. Then for the sampling team officer, on the field, they can see all the locations, the work assigned to them. So in this picture here, press the wrong key. So here, we can see there's a red dot. This red dot is the work pending to do. And this blue one is the work done already. Then for the officer, he opened his app, he can see the work list for him. For this one, lucky, just one job, right? Okay, so he will know where to go and what is the job assigned to him. Then we use the ArcGIS field map for collect the data. So when the officer arrives on the sampling locations, he will click the work he will do. So once he select the point, it will show red dot with the circle, blue circle. That is to show he is doing the job. He is collecting the samples on this particular location. So he will do, open this locations, what is the work need to do. For these cases, it's a pre-planned case, so there is a sample ID already, and also have a program, also have a schedule for that. So it will do accordingly to collect the data on site. When he perform all the tests, he will key in all the information to a simple form, here. So it's very straightforward. They won't miss anything, right? Okay. When they do everything, they take photos, send over to the LIMS, then you will get this information submitted to LIMS, and LIMS will provide this information, send to this one. They can use the portable printer to print out this label. And in the label, we have a 3D barcode. This 3D barcode is useful to us. When the sample bring back to the office, bring back to the lab, we can directly scan this barcode, and we know what to do, and there's a sample information directly input to the system. So no need to key in again. Okay, later I will do a very short demo on one of the case is like sampling, what is the on-site sampling workflow. And this is a training demo. We're using the dummy data to show that. Yeah, so the workflow on-site, if it's ad hoc, it's not planned job, it's an ad hoc. So the officer receiving the supervisor assigned the job to him. On the site, he logged into the mobile devices to make sure he was in the right place to collect the sample. Then after that, they will perform the test, keying all the informations and keying the test result as well. And also, he will take photo, not only the portable meter photo to prove the data they have done. Also, sometimes because it's investigation cases, they might have some issue for the sampling location, right? So they take photos or take even videos for that. They can upload this one to the system as well, and the system will go submit the data to our LIMS, and they have enough information, they can print out the label. So just have a very short demo on that. Yeah, so he went to the places, and the job ping for the places, he do the sampling, select the program, and select the test, the reason for sampling, and the schedule for the sample. Then after that, he will key in the actual address. So very straight for the sampling location, for the sampling points. Yeah. So after that, the postcode of that, and also keying the on-site data like temperature, total residue chlorine, pH, yeah, turbidity, all these field data. So directly keying. So once they finish keying all the informations, they will save it, and they will take photo. Then we will select the photo from the library. So for this case, we just select a portable meter reading. Then we will send over. We have the last, right, once we submitted, this label can be printed out, can be shown on the screen, and also can be printed out through the portable printer. Yeah. So this is a very simple. From the demo, you know, it's a very simple, very easy to use software, right? That is very great for our sampling crew people, because for them, they need to carry the portable meter on site, right? They need to collect the sample. If it's a very difficult software for them to fill in, no one happy to use. So for them, it's very simple. They just key in the data, they just take photos, submit it. yeah, it's very efficient. So data collection very efficient. Then for our officers in the lab, the supervisors, the management side, they can receive the data on time. No need to wait until they come back and key in the data. So they can release the result. They can release some alerts, if any, to the relevant staff. And the relevant staff, they need to do something for follow-up. They need to go to the site to check anything wrong. So all this is to make sure our water is safe. So it's ensure the water safety. So here I like to thank the Esri to help us to design and do a lot of customizations for our this WQSS. Not just working with our staff, we also need to work with the LIMS vendor. So at the beginning part, it really take a very a lot discussion, a lot times we spend, yeah, to understand the requirement, to understand the system. Also, we like to thank this support team, because after the system go live, yeah, we need to do a lot of change requirement, right? Fixed location need to change, program need to change, all these things, yeah, you have very patient and already very sufficient to help us to do all the changes. Yeah, thanks, thank you.